This is what it looked like in 1901. This is what it looked like now.
What's up, fams? My name's Emmanuel. This is my brother Myers.
Hi everyone! As you can see, I have hurt my leg. But that's alright. We are here at Thames School of Mines. It's a very, very old place. It first opened in 1886. That's like 130 years old. And we are going to be going through the whole entire building. I am so excited. But before we go, get a snack and a drink. Let's go. Hold on, wait a minute. Subscribe. It is starting to pour with rain, but that's alright. We're going to be inside because we are going through the school.
So 1869, the church was established in this building. They built a big church out here. 1885, they've moved the big church away and they've left this gable. This one wasn't here, just this part of the building. Okay, this gable was here. So we go into the 1869 Wesleyan Sunday School building. Just keep going through, folks. Thank you.
Holy.
So you can see it's very old building. 1869 was when this
Are those all potions?
Yes, they were, but they're not now. Okay. When the school closed in 1954, those jars were just left there. The property was bought by the Heritage Historic Places Trust in 1979, and it was only about 10 years ago, perhaps a little longer, that the substances in those jars were removed and replaced with inert substances. So right up until probably 10 or 12 years ago, those were the original chemicals that had been left there when the school was closed in 1954.
So is these the exact same potions?
Nope. No, those are inert substances, because if those were to fall off, when they were real, when they were the actual chemicals, if there was a shake and they fell off, those chemicals might combine in such a way to cause a reaction, which could cause a fire or could produce a gas. And
so is it the exact same bottles?
Yes, all the bottles are the same, but the substances that were in those bottles have been removed and replaced with inert substances, things that won't react. Let me tell you why the chemicals were there in the first place. For example, one of the things that miners needed to know about was gas, because in the Thames goldfield we have a thing called carbonic acid gas, which is a carbon dioxide gas. It's an asphyxiating gas, a suffocating gas. And one of the things that they would do in this place is they would recreate that gas. So they would combine chemicals together that produced a reaction, and that reaction would in part be the production of carbonic acid gas. Carbonic acid gas is heavier than air gas. So it's bubbling away here, produced, rolls off here, and sits on the floor. Okay, just like it would in a mine. So when the students walked through this room, they could feel the gas around their feet because it's denser than air. It's thicker than atmospheric air. Okay? How do we get rid of that carbonic acid gas? Because if we left it, it would fill up the room and we would suffocate. They had, over here, a slot in the floor, in the wall. And so that gas would just roll out and stop go outside and dissipate in the environment. What happens if they were producing a lighter than air gas? We have a hole in the wall, in the ceiling. And so that gas would rise up because it's lighter than air, it would go up into that cone, and it would be extracted outside.
That's pretty cool.
And the way it's pretty cool because the way they created the vacuum, which is what we call this extraction mechanism, is there's a pipe that runs across the top of that. And that pipe goes down to the outside of the building and then down to the ground. And into that pipe they shoot a jet of water, and that jet of water goes in and down. And when the water goes in and down, it creates a draft. It creates a vacuum. The air rushing across the top of that hole up there draws the gas up, creates a vacuum and draws the gas up. So that's where the lighter than air gases go. This is a chemistry laboratory, and that's the sort of thing that we're talking about. Look at the lights, those glass refractive glass gas lights.
That's old.
So back in the day...
Is this the exact same place?
Yep. This is a school for adults, not for children so much. This is a school that teaches adults how to mine. Okay, so the people that sat here would have been adults. Look at this desk here. Look how it's marked. Look at the hollow there. What might have caused that hollow?
The chemicals.
That's right. It's eaten into the timber.
Chemicals must be very strong.
Some of them are. They had acids here. One of the things that dissolves gold is a combination of acids called aqua regia. If you spill that, it's going to eat away the disc.
Is that a plan?
It's an elevation here. A plan is when you look down. An elevation is when you look sideways. Okay, so that's looking sideways at something. Okay, and that is a device for.
That looks like bricks.
It's a device for what? Lead chamber. That's to do with the cyanide process, how they get gold from crushed rock using cyanide. One of the ways we determine how much gold is in a rock is by using a thing called an assay process. Assay process is all to do with weighing things, chemical reactions and weighing things. Those weights, like those ones there, are used on these what they call balance scales, so that you can weigh your gold and silver, and you can weigh it and discover how much gold and silver you've got.
There's the scale.
As a percentage of the total amount of material that you put through the assay. Balance scales, so that's what they are. So this is the School of Mines in its 1886. Guys, if I can just take this book, we'll go back out to this room here. This book was produced in 1901, that's 120 years ago. This room is in this photograph. So if we go to orientate ourselves
This was
to
different.
this photograph, this was 1901, remember? The room's changed a lot. So we come down this way.
Oh, yeah.
Stand down here.
So
And we're looking from about over here.
basically.
So we're looking down that direction the same way the photograph was taken. Now there are some changes. If you look down this far corner, see the light there? It's a bright light. See where the door is? See the wooden frame above the door?
Oh,
There was a window. So they've taken the window out and put the door there. See how the end of the bench is in line with the left-hand side of the door? That bench has been shifted.
Yeah.
Or this photograph was taken before this wall was put in. And the person who took the photograph was standing way back out here somewhere. Okay? So what this photograph shows us,
And there's also these tables
Yes.
here.
that aren't there now.
There, and they were kind of.
And we see that gas distribution
Yeah,
mechanism coming
that's
down
not
from the
good.
wall so that they could put their Bunsen burners on the chemical tables here. So what the photograph shows us is that this is what it looked like in 1901, this is what it looked like now, and so there have been lots of changes in this room. But you don't have to look at the photograph. If you look at the walls and the floor, look at the walls, I beg your pardon, the floor, see how the wide boards are there? But look over here, the boards are narrow. Why would they do that? When they built the floor, they used the same boards all the way through, but later on there's been a fire and these boards have been replaced. Look at the boards on the walls and the ceiling, see how they're quite wide? But look at the boards on the wall here. They're narrower. So that tells us this was built in 1869, this must have been built a little bit later, and it was in 1890 when they added the offices and this partition wall. And it also tells us that if we know that this was built in 1890 and the school was started in 1886, we know that this photograph was taken before 1890, before this part was built. So here we've got all this deductive reasoning going on. We're beginning to understand what was going on in this building. We can see some changes. You son, you can have that picture. Come through this way.
It's very, very old. Oh, it's quite cold.
As the school rolled through it, as the curriculum changed, they got another wing built. This wing was built in 1890 as well.
A gold cart.
Now you need to think about what kind of things were taught by the school. I have that red book again, if I may. Because remember, this was a school for miners, people that are working in the hills, up behind us, over there, or in the stamper batteries. Let's look at the subjects that were being taught. I'm going to read them out very quickly. Mathematics, mining and applied mechanics, ventilation and explosives, heat, hauling and winding, pumping and pit work, land and mine surveying, metallurgy, practical assaying, practical chemistry, theoretical chemistry, general and mining geology, mineralogy and blowpipe analysis, Mechanical drawing, practical astronomy, physics and petrology. Those are really high-level university type subjects. And why do I say university? Let's go over a few pages and let's look at one of those. Practical chemistry, what are they talking about? The preparation and use of reagents, tests for purity, use of the apparatus and balances. These are really big subjects, very technically complex subjects. The miner is in the hills with his pick and his shovel digging away, and he comes down in the afternoon after work and he's learning these subjects, university level subjects. This door leads out here, and out here is an assay room. This assay room was built in 1890. And if you have a look in your book, you'll see a picture of this room. A picture of the room, and you will notice that it's very much unchanged. No, not that one. Can I use your book there, son? Oh, that's it. Good on you. So in 1901, that's what this room looked like. Look at it now. Pretty much the same.
Yeah.
Most of the bits and pieces are still here. You can see that piece of wood with a hammer on it. This muffled furnace is still here. You've got cupels here, crucibles here, flagons. You've got the gas chamber for experiment.
This is missing, I think.
What is
Yep.
there?
Gold rolls, that's not there. That's where you put the material to burn for the furnace. So that's a furnace, a brick furnace. Like a
These are
kiln.
wrenches.
Oh, this is gone.
These are picks.
That's the bench, is it?
Wow.
This room does assaying. And assaying is the determination of how much gold and silver is in a rock. To do that, you have to break the rock down to a very, very fine powder. To start with, you'd break the rock down using a hammer, and then you'd dolly it in that pot with the hammer, and then you'd take the material out of here and you would grind it. So that's hammering or crushing, and this is grinding. And you grind it to a very fine powder, and that's so that you release the most minute particle of gold from the quartz that was containing it. And then you could do the assay process, which was a process using fire and the sample with fluxes in the crucibles and then the cupels. And the end result of all that is a little button of gold and silver.
Hold on, wait a minute. Subscribe.
Look at the detailing. Look at the boards. That little bead machined into the boards. Okay. If you look at the window couch, it's sculpturally pleasing. It's got radiuses and curves. It's efficient and it's effective, but it's pleasing to the eye. Look at the window itself, with the architraves and the double hung sash window. You've got lots of little detail there. The Victorians like things to look nice as well as being efficient. Look at the pump, the small pump. Look at the radius curve. It's a beautiful smooth curve. Today we would be more geometric. It would be a right angle and it would probably have angles and planes as opposed to being round like that. The pump, it's only a model, but it is pleasing to the eye. It's an industrial thing, but it has an aesthetic about it that makes it different from perhaps its modern counterpart today. We'd do it virtually today anyway. We'd have it on a computer screen. Today we'd look at our iPhone or our iPad or our whatever. Here's what we would call a magic lantern today.
Is it a camera?
No, it's a lantern. It's for projecting an image. So you'd have a flame to produce light, and you'd have a slide on a wooden slide KC. You can see on the right hand side of the window, and that's the lens there. Get the book, put it on the table, go to the chapter index at the beginning of the book, look through it, select the chapter, go to the chapter, read the chapter, make notes from that reading, think about it, do some original thinking, write your essay or write your answer, and then present it. The map is important because it places the school in a relationship with the other components of town. Just get my glasses. The school doesn't sit here all by itself and do nothing. It relates to the industry it supports. And and the community it services. So here we go. Thames was started in Shortland down here. That was what we call the first CBD, Commercial Business District, okay? And then it was succeeded by Grahamstown up here. So, second CBD. That's where all the business was done. Over here, this is a place called Tukey's Town, or Tukey's Flat. That's where the big batteries were, most of them anyway. Shotover, Kuranui, Herald, Prince Alfred, Manukau, Imperial Crown, Caledonian, Golden Crown, and Waitahi. Here's where the gold-bearing quartz was produced, most of it anyway. Golden Crown Hill, Messengers Hill. So this is where the gold-bearing material comes from. This is where it's produced. This is where the business, the industry and the commerce is done that supports all of that. And the School of Mines was right here, where that word Wesleyan is. In 1871 it was the Wesleyan Church. We're in 1886, so that's where the School of Mines was. And we're right next to the CBD, right next to the processing, right next to the production. So the school's closely associated with the principal components of the town that it's supporting. Look at the names of the claims. They tell us about the miners, what they were expecting, just in time. They were expecting that the gold discovery would be just in time to save them from going broke. Where they maybe came from, Eureka Hill in Australia, Ballarat, big Eureka Hill conflagration. Where they may have come from, Lincoln Castle, Nebraska, Coringa in Australia, place names, Toronto, Canadian Montreal, where they may have come through, either come from or come through as gold miners. What they were expecting, here's one called the multum in parvo, Latin for much and little, basically, that's what it means. Gold's very small, but it has a big value. Much and little, okay? Long drive, longest tunnel on the goldfield at the time the claim was registered. All nations, there were 7 nations represented by the 7 individuals that registered the company.
That's the tunnel there.
Yeah. So those names talk to us about the people on the goldfield. Really, really kind of quite neat. So this building was built in 1900. It was built to house the expanded mineralogical collection.
Whoa!
And the mineralogical collection is a big collection of rocks, and it's really boring.
That's cool.
Because it's just a big collection of rocks. But I'm going to tell you what it was here for. Subjects of instruction.
Oh.
This is a visual aid for some of these subjects, and those subjects are the ones that are interesting and that relate to here. Metallurgy, practical and theoretical chemistry, mining geology, blowpipe analysis, and petrology. Those are things to do with stones and the discovery of what those stones contain. So this is a big visual aid supporting some of those curriculum subjects. What does it do? Very quickly, we won't talk about the 3,500 exhibits that are in here, we'll just talk about a couple of things. Firstly, miners dig holes in rocks. That's what miners do, they dig holes in rocks, okay? So they need to know what that rock is. On this side of the Coromandel Peninsula, the rock is andesite. Andesites, here they are, big geology. On the other side of the peninsula, the east coast, they are rhyolites. Here they are, rhyolites.
So this and that.
This is on the other side of the peninsula. This is on this side of the peninsula. So you're a miner digging a hole in the rock, you need to know what the rock is. This is what the rock is, andesite. Huh? Then you need to know, well, what does the thing that I'm looking for look like? Because I'm not looking for this rock, I'm looking for what this rock contains, which is auriferous material, gold-bearing quartz. So what does the gold-bearing quartz look like? So we come down here, and we see an example. Now, it doesn't come from Thames, and I'll show you a Thames piece. Here's a piece of auriferous quartz. It comes from Ballarat, Australia. And why do I use this? I'll show you why. So firstly, the quartz is the white. That shows you what that auriferous, that quartz rock looks like. Then you see the 3 dark blobs. That's the contaminating mineral. In the middle one, the middle blob, at 1 o'clock, up here, see 1 o'clock? You'll see a little gold piece. Can you see a little gold piece here? So the middle sample, 1 o'clock. So this sample shows us what the auriferous material looks like. It shows us what the contaminating minerals look like, and it shows us what the gold looks like.
Yeah, I can see that, yeah.
So that's what Australian auriferous material looks like. What does New Zealand or Thames auriferous material look like over here. And this is what the miners in Thames are expecting to see, this kind of rock here. If you look down at the bottom, there's a really nice example. It's not gold, I know it looks like gold. It's chalcopyrite, iron or copper pyrite. So that's what the miners are looking for. That's what they're going to find in Thames. But that's not the gold. What does the gold look like? We come across here and we see this one here, New Big River Mine, and the schist here. Can you see this one?
Oh, yeah,
you see the gold there, eh?
see that.
Now that comes from Lawrence in the South Island, but it shows us what the gold looks like. Now all through this collection there are bits of Thames rock that contain gold. So the miner can see what the big geology is, can see what the auriferous material looks like, and can see what the gold in that auriferous material looks like. It shows us the rock that the miner is going to be hopefully finding and identifying what the gold is going to look like.
Is this amethyst there? This one?
That's what we call amethystine quartz. Yes, it's a weak form of amethyst here. It doesn't have the deeper purpley colour. Amethystine quartz, so it's got an iron mineral in it that forms that light blue colour. If you're a miner, you need to know a little bit about mining. You need to know about what this geology does to your bits and pieces, your utility assets. Have a look over here. Here's a couple of wooden structures down here. See those wooden squares or rectangles? And see how they're filled with something? There's a pale white one on the left and there's that orangey browny one on the right. So those are water pipes. They're bits of water pipe. And they've had water that's come from very deep underground.
Wow.
And that water has contained something called calcium carbonate. And that calcium carbonate is deposited on the water, on the wood. And look what it's done. It's filled the pipe with that sediment. So it's reduced the flow, it's reduced the volume. So miners need to know about that, because if they've got a pipe that's carrying water from deep underground, they know that the calcium carbonate that's in the water is going to eventually block the pipe. That pick that you were looking at before, see how it's been corroded?
It's been underwater.
The water in the Thames mines has a very weak solution of sulphurous acid, and the sulphurous acid will corrode the steel. Look at the rope. The rope was left underwater in a mine for.
Oh, that's rope.
Okay. What's it done? It's absorbed the calcium carbonate from water and it's fossilised like a piece of petrified wood. Miners need to know about that. Look at the water pipe down here, the steel water pipe. Here's a piece of steel water pipe. Look how it's pitted. It's got this mountain range on it. Ferrous carbonate from the water has deposited on the surface of the pipe. And it's caused that irregular deposition, that irregular surface. And so that means the water is going to be turbulent when it's flowing through, so it's not going to flow through the pipe efficiently, and it's also not going to carry so much volume. Miners need to know about that. They need to know that the water in the Thames from depth carries calcium carbonate and ferrous carbonate. And that those two substances are going to have an effect on their utilities, their pipes and their pumps and those sorts of things. So that's what the collection does. It talks to the practicality of mining in this area as well. One final thing, which has got nothing to do with mining. Here's a certificate. It's given with a medal to a bloke called Lois Melhose, who was a miner and a share broker and a merchant, I think, in Thames. 1886, presented by the Colonial and Indian Exhibition. This is Her Benevolent Majesty Queen Victoria, Queen of the Empire. Here is the empire here. One of the biggest empires that the world had ever seen.
Looks very nice.
It's a beautiful work of art.
Wow.
How does this artist see the empire? As females.
Hold on, wait a minute. Subscribe. Thank you everyone for watching. Don't forget to subscribe and smash that like button. We will see you on our next adventure.